making some form of calls to an API. You can also check the site because people are very happy when people create applications that interface with them. And you can use tools because it might not be obvious that you have a widget or something installed in your web browser that is making calls to an API. So I wouldn't know that most people that install, say, social network applications, I would say that most of them wouldn't know that they're making some sort of backend API call. But you can see those if if you're doing a inspection proxy in your browser, like you'll see those calls going out. And from a zero knowledge perspective, most of the reason why those aren't published is because they're for internal use only. So maybe, like say Hulu, for instance, maybe they only want to create a desktop application that they can use and they don't want to open it up to everybody. Or maybe they want to have some sort of developer vetting process, so not just anybody can create an application that interfaces with their service. Because sometimes that kind of makes sense because you have people creating like crappy applications that then make your service look crappy, so that kind of makes sense. And documented is where you get, obviously, full win, and that's typically the case because people put this stuff out there. So because the larger user base, the more popular your application becomes, and that's really what it's come down to. Everything nowadays is integrating with something else. There's not a lot of static websites left out there. So it's all about a functionality arms race between you and your competitors. So that's pretty much what it's come down to. And what you also get with not only identifying that, one, there is an API there, and two, structured data, you also get architecture information and capabilities of the API. So when you're going through looking at the API and you're doing kind of this functional review and you're trying to determine, hey, I want to know what this thing does and how it does it, you basically have that all documented there. It's your capabilities and the depth of the API into the application. One of the things that Google came out with was Open Social, and it was originally meant as an API for social networks, and then they decided that, hey, this is a great idea. It's not only for social networks anymore, anybody can use this API. There are some people that think that, wow, all of this functionality I get with this API just isn't enough, I need more, so they'll end up extending the API even further. So those are things that you would find with documentation as well. So even if you recognize that somebody was implementing Open Social because maybe you saw some Google-oriented type code in there, just be aware that they may have extended it even further. So it might go even deeper into the application, be way worse than you thought on the surface. Because when you implement somebody's third-party API, you're swallowing up all this functionality that they originally intended, which you may not even need. And typically, it's the kitchen sink up front, and then you just kind of take off what you don't need. And in that case, you may be allowing people to make calls to things that you never intended them to make calls to. So you get that, you get the extended API documentation, and you also get case information. So not only would it tell you how to do something, it would probably tell you why to do something. So in this case, you would want to do this. One other type of API that would be hard to identify without any documentation would be server-to-server APIs. So if you kind of have something in place where content from another server is being called and placed onto another server, there's no client-side interaction with that. So from a testing perspective or from a user perspective, you would never see the data going back and forth between servers because none of that is like leaked to your web browser or your client that you're using. And also with documentation, you get some win from modules that make calls to the API.
So what about latencies for server-to-server communication? Are there going to be a lot of things you can deduce from timing to be able to tell whether or not you're actually having back-end calls?
Whether it's making back-end calls, you could. But as far as like structure and how it's happening or what the calls look like, the question was, what about latency for back-end calls? Would you be able to deduce that something is making a call there? It would depend on the site too, because maybe you're used to it being horribly slow. But it would really be hard to identify the call and what the call looked like without any kind of documentation.
A good example would be Amazon. I know for a fact that when you pull up their main page, they make about 250 back-end calls.
Yes.
Right, so they scatter them all at once and gather them back together. And obviously they're not a slow site.
Yeah, exactly. Yep.
If it's well implemented, you're going to have a really hard time seeing whether it's, but if it's a big site, it's obviously not.
Mm-hmm.
You
Well,
can't scale it on one box and therefore.
also, too, back-end server calls on the same network are obviously going to be much quicker, too, than back-end calls that are going to different, servers around the web. So that would be another thing, too. So these language-specific modules will also help a lot if you're trying to create a malicious client and do things like that. Obviously, popular languages like PHP, Python, Perl, and others as well. And I decided to put a couple examples in the presentation you can click on later to kind of mess around with, because I'm talking about it kind of almost from an abstract perspective. Like I've talked about APIs, but I haven't shown what any of this looks like. So hopefully I'm not getting too many glassy eyes. I don't think so, but so there's a couple for some popular websites. When you're going through the documentation, or whether you're using a zero-knowledge perspective, you might notice when you light off your web browser and you load something up and you're inspecting everything that's going on with an inspection proxy, you might see tons of calls everywhere. So you'd really have to pick and choose which ones are kind of calling APIs or which ones are calling functionality that you weren't aware of. You're going to want to not only determine the depth of the API into the application, but also what functionality is available to the API that aren't available to your quote-unquote standard users. And usually those are for, require elevated privileges. So those are going to be interesting. Also, is there any segregation between the API calls and the actual application itself? Because that would definitely cause a problem. So if your API and your application are one and the same, basically, and you're integrating content, now all of the content that you're integrating into your application is now rendering on the same canvas if it's a web application, which can be very bad, as we'll see later. And basically what I just said. How is your content integrated? Is it integrated into the same domain? Is it rendered on the same canvas? Are you creating multiple pathways to similar functionality? And where that becomes a problem is when it comes to fix time. So if you find a bug in something and you fix it in one spot, now you need to fix it in multiple spots, which often gets forgotten about. So you may have a bug that you identified a year ago that's still available through your API, that because of and bugs not only from a coding perspective, but from a session management and authorization perspective. So you may be providing standard users with elevated functionality through an application, and through the standard interface that you developed, they don't have that functionality. What is the structure of the call? Like, what does it accept? What types of data formats are you dealing with? So once you understand that, it makes it a lot easier to understand how to violate it. So obviously, if you're using like SOAP, you know that there's supposed to be a standardized envelope, and if you mess with that too much, you know what you should expect to happen. But you can do all the same web application attacks against API calls that you can against standard applications. So if you're talking about trying to do some things with JSON or XML, those are defined formats, and if you can violate those, then it's win. And also the type of transport. So what type of service are you dealing with when you're sending data back and forth? So here's a simple API call, and this is one that I did a while back when I was messing with Google a little bit. So there are a few things that you should notice about this, and hopefully it's big enough for everybody to read. One is you should see it appears to be a standard HTTP GET. So that should be pretty obvious. So this whole thing is contained in a GET request. The other obvious thing that would be interesting if you were testing is you should see that it's a call from one domain to a completely different domain. So it appears to be pulling content through something called a proxy, which should be something else that would be interesting, and it appears to be retrieving that content. You'll also know that where it says OpenSocial_URL, you'll also notice that somebody thought about content encoding on that. So it's URL encoded, and it appears to be signed with a token. But that doesn't mean anything, because even though it says auth type equals signed and there's a token, this was something that got horribly violated during a different talk in 2008 that we gave at me and Sean Moyer purposely pronouncing his last name wrong because he used to do it to me all the time. Me and Sean Moyer did at Black Hat 2008. So that's what, and throughout the rest of the talk, I'm going to use like simple examples of, you know, just a standard get to show how these things are violated. But it could be in any format. So here's an example for Delicious. Can anybody tell me what type of web service this is? From looking at it? There you go. If I had a prize, I would give it to you. It's a RESTful web service because it's using all of the methods. It's using get, post, put, and delete. So, and just from looking at this should be interesting is that it doesn't say anything about authentication, like in just what I showed you. It doesn't say anything about authentication and session management. So, if you just, you know, decided to post out to add a bookmark to quote-unquote username, you know, what would happen? And those are the types of things that you want to be thinking about when you're testing. Is anything that seems to be static in nature, especially, anything static should be attacked. It should be violated. The structure should be analyzed. Well, I'll get into that when I get into the fat client stuff. And of course, bolting on, which is popular with people who have had applications out there for a long time and now need to provide some sort of functionality. Even if it's not for external consumption, even if it's only for internal consumption, you know, bolting on APIs can, I mean, there's nothing wrong with doing that. It's just the thought process and the design needs to be there because fixes are often not integrated and you're once again potentially creating multiple paths to the same functionality. What I've seen happen quite often is the wrapping of services. So you might not want to create your own instant messaging framework or chat framework within your application. So you may look elsewhere for services that provide that, and then you might want to wrap it in your client. Well, that's all well and good, but when you're wrapping something, you need to be aware of all of the functionality that's available. And from a tester, that's great because usually these other services are very well documented. A simple example would be, you know, I have a site and I want to create a chat framework and instant message framework, but I don't want to write the backend code. So maybe I'll wrap Jabber up in my front end. But Jabber has some interesting things by nature because it's open. So if you weren't aware that you can just register as a new user by just, you know, registering on the Jabber service, that could be a huge problem. Because now you have extra functionality. Also, think about the fact that maybe you can use your own client to connect to that. And yes, once again, I am standing up here talking about something on Adult Friend Finder. It's just funny to me, but that is using iChat to connect to the Adult Friend Finder messaging service because it's just Jabber. So they had this intricate front end that was written in Flash that I never did like fully take a look at. I just noticed that it was calling Jabberport, so I assumed that it was Jabber. When I lit up iChat, I directly connected to it, and I found out that the security policy that was pushed, basically, the restrictions that were placed on the Flash client were no longer there because I had used my own messenger to connect to that. So those are the types of things to think about when testing services that appear to be wrapped or when you're in the design phase of doing, you know, implementation. So identify functions that you definitely don't want your users, you know, taking advantage of, and you know, putting in place restrictions properly. So fat client applications. Increasingly lately, we're having more and more fat client applications that are just using HTTP as a transport protocol, which obviously there's nothing wrong with that, but that opens up some things as well. So one of my favorite things is Dropbox. Now I love Dropbox. I use it all the time. I love their new shirt contest, which this was actually on a shirt, and it says, "It just somehow works," which is kind of how sometimes we take everything. It just somehow works. I just know I drop things in this folder, and automatically it gets synced online through some form of magic. But just because it's a fat client application doesn't mean there's not client-side functionality that we can't analyze and take a look at how it's used. And so from that perspective, you may notice if you use Dropbox on OS X, you can right-click on files in your Dropbox, and there's a couple of options where it says browse on Dropbox website and view previous versions, because there's version control with Dropbox. If you click one of those links, it automatically opens